So again, if you look at your physical geography part 1 review, again, pages 32 through 39 focus on natural processes related to plate tectonics. We actually know that, the movement of the Earth's plates give us certain natural disasters, most notably, earthquakes, tsunamis, volcanoes. They are the direct result of the fact that the crust of the Earth isn't as solid, as we've always thought it was. It is a combination of continent-sized plates resting on magma, which again is molten rock. So we move into pages 40 and 42 in the textbook, which you don't have to read right now, but again, it's in your review just so that you have an additional guide. Again, I've made mention of this before. I will post a video with me talking over it. Okay, I'm going to be doing that. I know people have different skill sets when it comes to taking notes. Some people are very good at taking notes, in the moment. Other times, people who are more, auditory or visual learners, it's better for you to, sort of listen first time around and then maybe go back and, make notes in the aftermath. That's all fine. Okay, but I do want to let you know that, again, just relying on me recording these videos so that you have a wealth of information at your fingertips doesn't necessarily mean that you have as deep an understanding of it. It's a good way for you to challenge your understanding is to use the PDFs of the textbook to, again, look through them again, look at key vocabulary, just that you're hearing it in a different way. The brain works and absorbs things differently, right? We talk about kinesthetic learning, auditory learning, visual learning. So this might be a helpful tool for some of you, and that's why I record these videos. But at the same time, use the provided textbook and the guide, pages 40 to 42, to have an additional tool to help you have a deeper understanding of how these things are put together. Now, when it talks about landform review, again, in this particular PowerPoint, you might look at this and be like, I don't actually recall us doing Canada's landform regions. And you're correct. Okay, we have not done that yet. That's actually going to be part 2 of our physical geography unit. This first half deals more with, natural processes, climate, the rock cycle, plate tectonics, glaciers, erosion, how the landscape is shaped and formed. And then in the second half of the unit, that's then we're going to focus on, all right, what does this mean for us in Canada if we look at, Canada's incredibly diverse landform regions? And again, that word gets thrown around a lot, diverse. There are different contexts in which you can use the word. When we're using it from a geography standpoint, when we say diverse landform regions, we're saying different landform regions. And I mean, if you look at postcards across Canada, you'll see that, areas of British Columbia look very, very different than the interior of places like Alberta or Saskatchewan, which again are going to look very, very different than this big green one here, which is actually known as the Canadian Shield. And if you've ever actually been up to, Algonquin Provincial Park, which is a pretty famous one as far as, in close proximity to us, you'll know that the landscape up there, and as you move into the Muskokas and cottage country, it looks and feels different than actually where we are. We're in this actually little orange one down here, the smallest landform region, believe it or not, off the shores of Lake Ontario and Lake Erie, and this is Lake Michigan over here. Oh no, sorry, that's Lake Huron. What am I saying? Sorry, Lake Michigan's over here. Wow. Can't believe that that's recorded. Sorry, it was just, I wasn't really paying attention. And so anyway, in this close proximity to the Great Lakes, this is actually why we call that landform region the Great Lakes St. Lawrence Lowlands. And believe it or not, here's a fun bit of trivia for our next unit. Over half of Canada's entire population lives within this orange landform region. I know, the smallest one. Over half of Canada's 35+ million people live in this little orange section, which is kind of crazy to think about. More on that will come. What I would like to do is to, and you may remember this from elementary school, there are different types of rocks, okay? And I have good news for you. If you're worried and you're like, oh my goodness, is this gonna be like a geology class where he's gonna bring in like a big bag of rocks and we're gonna have to spend time identifying them? No, all right? That's not what we're doing. I'm not here to trick you. I'm not gonna, give you, core samples of different rocks and say, quick, tell me which one it is. But I do care about the process, the natural processes that connect to plate tectonics that explain how we get these different types of rocks. Because that actually helps us to connect the dots when we look at our landmass and we understand. And again, you might be like, oh, rocks and soil. Oh my goodness, this is so boring. When are we going to talk about other things? Well, how about gold? Do you like gold? Do you? Maybe silver, other precious metals? What's kind of interesting is that when we look into, the devices that you hold in your hand a lot of the time, your smartphones, they have their origins in what we call raw materials. Okay, you don't get something from nothing in the natural world. And so the raw materials, the metals and, the silica, for glass, and the lithium for the batteries, these devices that we use, whether it be a computer or a tablet, anything that is manufactured, the things that make, life more fun and interesting, the fun tools and toys, they all have their origins in what we call raw materials, and they have to come from somewhere. And mining is one of the methods in which we gather those raw materials. And so finding the right materials that we need actually has a lot to do with the different types of rock that you're looking at and that you're dealing with. So I'm going to do this fairly quickly in the recording because I have a couple of videos that I think already do this, and they're more interesting than me just talking over it. But as a recap, sedimentary rock, you see the word sediment, you often think of things like dirt and soil. Sedimentary rock is formed by slow erosion, the breakdown of rock over time that eventually compresses and forms rock. And actually, if you walk not too far from the school, actually, Lions Valley Park in Oakville, if you look into that valley, you'll see, hey, this looks fairly familiar. You see all of these layers. That's actually the result of sedimentary rock. So it's the result of erosion and breaking down, dust, dirt, and sand, compressing over time. Igneous rock. Sorry, my my voice is cracking there a little bit. Got to make sure that I stay hydrated. Igneous rock, and you'll see in the Bill Nye video I'm going to share, igneous shares a similar root to the word ignite, like fire. This is sort of the origins of all rock, really, if you think about it, because igneous is cooled magma or cooled lava. All right, once it cools, it goes from molten rock into what we call igneous rock. And there's lots of different variations of it, depending on the circumstances of where it cools. And we saw that interesting video in class that looked at, sometimes underwater volcanoes, and when, the cold lava, meets when the hot lava meets the cold seawater, there's a really violent and visceral, transformation of the cooling of that rock. It's really neat. And again, how does it form? Cooled magma. Okay, that's what igneous rock is all about. Again, looking at some samples here. And again, I'll post this PowerPoint if you're like, oh my goodness, you're going so quick. Don't worry about it, right? This is a recap of this particular PowerPoint, which I'm going to share with you, which is only one tool to help you have a better understanding of how these things are put together. A secondary tool is the textbook reading, and a tertiary or third tool is actually going to be a couple of the videos that we will be looking at. Metamorphic rock is caused by heat and pressure. You might say, wasn't that the same as igneous? Well, the big difference here is that it doesn't actually melt. Okay, if it were to melt, whenever rock melts, that's like hitting the reset button and it becomes magma again. So if you have existing rock, whether it be igneous, or sedimentary, eventually what can happen is that through heat and through pressure, it can actually take on different characteristics. And that's actually what we call metamorphic rock. And again, you do not have to take my word for it. I'm going to pause the recording because we're going to transition to a couple of videos. So this is kind of part two. The first one was talking about the rock cycle. And then we took a bit of a break, and there was a Bill Nye video that we included that talked about weathering and erosion. Okay, erosion can happen many ways, whether it be wind or air or water, very destructive. One of the biggest impacts of erosion on the natural landscape is that of glaciers. Again, as I said before in the video, you're going to be watching known as nature's bulldozers. So we are going to walk through this fairly quickly. Again, so what is a glacier? It's basically a mountain of ice, and it occurs over a long period of time. Snow will fall and then will continue to fall and continue to fall. And especially in areas where the temperature is below freezing for a large part of the year, the rate at which the snow falls and the cold temperatures allow these mountains of ice to continue to remain. They actually do, and we're going to see that they move. Okay, glaciers actually move a lot, even though at first glance it appears to just be sort of this stationary wall of ice. They move because of just the sheer weight and gravity. And they also move because from time to time there are portions of it that will begin to melt. And we actually call that melt water. It can sort of act as a bit of a conveyor belt. Canada's landmass and climate supports approximately 20% of the Earth's glacier ice volume, excluding Antarctica and Greenland. And so it is theorized that at one point, and I think that that's going to be one of our other videos. What is glaciation? Well, that is the process of ice advancing and covering large areas of land. And again, we should clarify here that this is not the same as like a snap freeze, right? So if you're like, oh, I know in Texas, they had a blizzard and they're having problems. Is that what we're talking about here? No. Okay, that is not glaciation. That was a freak snowstorm. It was a blizzard. Those sorts of things can happen. But glaciation is when, I don't want to call them permanent because they can disappear over time, but large walls of ice will grow and cover the landscape. It is not something that happens quickly. It is something that happens over long periods of time. And as I said before, ice can actually go through the process of growing and retreating depending on the conditions and on the year. This is, again, a theorized depiction of what climate experts and geologists predict at one point Canada actually looked like. Okay, and again, this is we cannot quantifiably go back with picks and determine that this was the case. But if we look at some of the data from the way that the landscape is shaped and the way that it's carved out, and you sort of connect the dots, we see that it's theorized that at one point, essentially all of Canada was encased in ice. So this is one of the reasons why, we in Canadian geography are at least going to reference glaciers, whereas, other countries, especially tropical locations, they may not talk about them at all. Again, here we have some historic pictures of different glaciers over time. And again, you don't need to memorize this slide, but glaciers do move and can very much impact the landscape. They can carve out pieces of land. They can also deposit and leave things behind. Um, it's kind of like, I mean, a good example of this on a much smaller scale is that, you know, sometimes with snow plows as they come by, you know, they'll make these gigantic piles of ice and snow in your neighborhood. Sometimes, you know, you'll see them in like parking lots, for example. You'll see like a big pile of snow that has been, you know, put there by the snow plow, by the bulldozers. And often the snow is really gross. It's really dirty. It's often full of like sand and silt and dirt. Eventually, once that massive ice melts, all that's going to be left behind is all the dust and the dirt that was stuck in that ice. And it can actually be a pretty significant pile. So that's kind of a much smaller scale example of what deposition is. It's basically when a glacier melts, it leaves behind all the stuff that it's collected over time. And I have a couple of videos that I'm going to share with you briefly. And again, this is looking at, again, the theorized retreat of glaciers, you know, going back, you know, over 14,000 years ago, as they, you know, carved their way and made their way into what is now the Great Lakes and carved out areas, you know, the water began to melt, and water will always follow the path of least resistance. Okay, I'll say it again. Water will always follow the path of least resistance. And this is why in the Bill Nye video you watched when it was talking about erosion, said why sometimes, you know, you have valleys. You know, the valleys are carved out over time as water continues to flow, and it's just going to make the valley even deeper because the water that makes its way through that area is always going to, by gravity, take the easiest path. And so again, eventually, you know, we have, and we've talked about, you know, 4,000 years ago, you know, that predates colonial, you know, history in North America. And I say colonial history because it doesn't mean that there weren't people here. Okay, we had First Nations people that were living in these areas, you know, 4,000 years ago. But you know, Canada as we know it, you know, founded as a colony of Great Britain, or even, you know, the you know, empires waging war, you know, the English, the Spanish, the French, trying to lay claim to the New World, you know, had not happened, you know, that long ago. And so I'm actually going to pause the recording portion again because, you know, for copyright purposes, we're actually going to transition into a couple of the videos that I will post on YouTube, but we're going to watch them together, and we're going to see glaciers increasing in size over time. We're also going to see a visual representation of the deposition and the movement of the glaciers. So I'm going to stop the recording.